Welcome to this series of Shearwalls tutorials on the description and explanation of the results obtained from the analysis. This series of tutorials is based on the Shearwalls US version 10. Output results in the Canadian version are similar, thus any difference between the two will be explained in another tutorial addressed specifically to the Canadian version. This tutorial will walk you through all of the results in Shearwalls. First, the results are available from the Results View icon in the toolbar. The project information, such as the company and project information, design settings, and site information can be found by the Go To table and then Project Information. The company and project information table is only activated if information has been entered here in the corresponding settings in the Company Information and Project Description tabs. The first row of information shows the codes and standards used for the design. The next row includes the load combinations for wind and seismic, as well as the building code capacity modification factors for wind and seismic load cases. The load combinations for the design as well as for deflection criteria are shown. Unlike Shearwalls version 9, where it was possible to modify the load combinations, Shearwalls version 10 does not allow for modifications, as both ASC 7 and IBC have adopted the same factors for allowable stress design and strength level. Therefore, there is no need to modify the factors anymore. For more details, refer to the tutorial entitled Design Settings. The building code capacity reduction factors for wind and seismic are found in the Design Settings. The default values for seismic and wind are 1, but there is the possibility of adjusting the capacities based on the local building practices. This option was introduced in the program because at least at one time, some cities, for example Los Angeles, required a 25% reduction in shear capacities for seismic design. Therefore, the default value for designer in LA would be 0.75 for seismic. Let's look at a simple example. First, draw a rectangle, add walls, a flat roof by selecting the flat roof option. We will now generate the loads and run the design. To access the seismic design shear results, we'll have to go to Table, Seismic Design, Flexible or Rigid, and then Shear Results. Looking at line 1, level 1, we can see that the shear capacity for the exterior panel is 200 pounds per linear foot. Now change the building code capacity factor from 1 to 0.75. And now rerun the design. Looking at line 1, level 1, we can see that the exterior allowable shear capacity is now 150 pounds per linear foot, representing a 25% reduction in seismic shear capacity. The same concept would be applicable for the wind reduction factor. Going back to the explanation of the design results table, the third row in the results of the design settings includes the service conditions and load duration, as well as the maximum shear wall offset. The load duration factor found in the results is the 10-minute load duration factor used for determination of all capacities in the analysis and is hard-coded in the software. The temperature conditions in the results are found below the service conditions in the design settings. 3 temperature ranges are available. These ranges are for the temperature factor CT for connections, used to determine the withdrawal capacity of the nail, which is defined in the National Design Specification for Wood Construction in the following clause, while its value is found in the following table. The service conditions for moisture content at fabrication and in service are found in the design settings here. When the Include Deflection Analysis tab is unchecked, the option for both at fabrication and in service is either greater than 19% or smaller or equal to 19%. In that case, where the Include Deflection Analysis tab is unchecked, the moisture content at fabrication and in service is used in the determination of the wet service factor, CM, to determine the withdrawal design value of one nail for the component and cladding analysis. The wet service factor is determined from the following NDS table, and it is then used in the equation to determine the nail withdrawal capacity presented in the following NDS table. Along with the reference withdrawal value determined using the following equation and the temperature factor. If the Include Deflection Analysis tab is selected, the program allows the designer to enter precise moisture content at fabrication and in service, as it is used to calculate the shrinkage component of deflection using the following equation. The equation is found in the legend of the hold-down displacement table in Seismic and Wind for both rigid and flexible analysis. The equation is located in the legend below, while the resulting shrinkage is presented under the following column. The length subjected to shrinkage can be found from the Go-To table, Structural Data, and Story Information, where it is displayed for every level. The length subjected to shrinkage can be entered from the structure icon for every level. If you cannot see the input form, simply select the Form View icon and it will be displayed. The program then uses the same method to determine the withdrawal design capacity than when the Include Deflection Analysis tab is unchecked by comparing the fabrication and in-service moisture content to the same limits, smaller or equal to 19% or greater than 19%. Appropriate factors, taking into account the choice for in-service moisture and temperatures conditions, are applied to nail withdrawal strength for components and cladding design and are shown in the Wind component and cladding design results table. Going back to the design settings in the results view, the maximum plan offset used for the analysis found in the results is entered in the design settings here. The maximum plan offset is the maximum separation between parallel walls on the same building level to be considered into the same line and was first introduced in Shearwalls according to the prescriptive design provisions of the 1995 Wood Frame Construction Manual. Although the special design provisions for Wind and Seismic, also commonly referred to SPIDWIZ, is silent about plan offsets, the software includes a default value of 6 inches to provide a tolerance for the automatic shear line generation routine. The maximum elevation offset is the maximum separation between parallel walls on different building levels in order to consider them along the same shear line. The IBC and SPIDWIZ do not deal with maximum elevation offset either, but a value of 1 joist depth is set as default.